Today's lesson is taking integrals of things involving logarithms and exponential functions. So if we have the integral of 1 over x, that is going to be the natural log. So the derivative of natural log is 1 over x. So the integral is the natural log of the absolute value of x. So we've kind of already talked about this, but the domain of this is all real values. So we want to be able to find the integral at all of those. But natural log is only defined for positive values. But the integral will be equivalent on the positive and the negative. For this one, you could do a u substitution if you want. Make it u equals 4x, which means du is 4 dx. So that means we need to undo that. So we'd have 1/4 times the integral of du over u, which would be 1/4 natural log absolute value of u plus c, which is 1/4 times the natural log of 4x plus c. Now some of you are able to see this right away, and that's fine. You don't necessarily have to do the substitution if you can do those calculations in your head. Here, this is just going to be the natural log absolute value of x plus 2. And remember, you can always check the indefinite integrals by taking the derivative. If I take this derivative, it's going to be 1 over x plus 2. Here, this is the same as like 1 over x squared. So this one's integral, and you should be able to recognize it, but if you don't, maybe rewriting it as a power will help, to the -2. Why did I do a u? X. So this, if I added 1 to the exponent, is going to be negative x plus 2 to the -1, which is equivalent to negative 1 over x plus 2, just 1 over x plus 2 plus c. So the integral here that we're working with is 1 over x squared. The derivative of 1 over x is negative 1 over x squared. So the antiderivative of 1 over x squared, or in this case x plus 2, is negative 1 over that. So the case here is this doesn't have a power, this one does. So this is not a natural log, this one is. Here, this is going to be, let's let u equal 3x plus 2. And again, if this isn't helpful for you, then you can just do it in your head. So 3 dx. So I want a 3 dx, which means I'm going to change that to a 1/3. So doing my u substitution, this is going to be 1/3. 3 dx is du over u. So this is 1/3 times the natural log of the absolute value of u plus c, which is going to be 1/3 times the natural log, the absolute value of 3x plus 2 plus c. Okay, we'll do again. Okay, we'll do that same thing here. So we'll let u equal 3 minus 4x. So du would be a -4 dx. So I'll make that a -4 and undo that with a -1/4. So this is -1/4 times the integral of du over u, which is -1/4 natural log absolute value of u. And then we will replace u with 3 minus 4x. So both of these followed this pattern where the denominator was just a linear function. So we can generalize that. On the outside, we had 1 over 3 and 1 over -4, which is coming from that coefficient, which in this case is a. So 1 over a, natural log, ax plus b plus c. Here, this is going to be natural log x plus e plus c. Nope, not plus c, because we're doing a definite integral, e. So this is going to be the natural log of the absolute value of e plus e minus the natural log absolute value of 0 plus e. So we have the natural log of 2e minus the natural log of e, which is just 1. All right, so you should see that the derivative of 5x is here in the numerator. So we're going to let u equal x to the 5th plus 1, which means du is conveniently 5x to the 4th dx. So this is going to be the integral of du over u, which is the natural log absolute value of u plus c, which is the natural log of x to the 5th plus 1 plus c. Here, we'll let u equal 1 plus tangent, which again, conveniently, the derivative of that is going to be secant squared. So this is the integral of du over u, which is natural log of u plus c, which is the natural log of 1 plus tangent of x plus c. Here, we're going to have u equal 1 plus sine 3 theta. So du is going to equal 3 cosine 3 theta. So I sort of have that. So I'll add a 3 there, or multiply by 3 and do a 1/3. So this is going to be 1/3 of the integral du over u. So this will be 1/3 natural log of absolute value of u plus c. So 1/3 natural log 1 plus sine 3 theta plus c. So all of these three, we had the function and its derivative on top, the function, its derivative on top, function, and its derivative on top. And the result was the natural log of the function. So the integral of g prime over g is going to be the natural log g of x plus c. So tangent is going to be, we're going to rewrite this as sine x over cosine of x. Okay, we're going to let u equal cosine of x, which means du is going to be negative sine of x. So this integral is, we can rewrite using the u substitution, is negative integral of du over u. So this is going to be negative natural log of u plus c, which is negative natural log cosine of x plus c. So there are a list of integrals that you need to know, and one of those is tangent. So tangent of x, the integral, is going to be negative natural log cosine of x plus c. Now we're going to do the same thing with cotangent. So cotangent is equal to cosine over sine. So we'll let u equal that denominator of sine x. Du is then going to be cosine of x dx. So we'll rewrite our integral as du over u. This will be the natural log, absolute value of u, which is the natural log of sine of x. So this is another one we need to know. The integral of cotangent of x dx is positive natural log absolute value of sine of x plus c. But we saw we could pretty easily derive it as long as we know what the integral of 1 over x is. Our next one, we're going to let u equal secant x plus tangent of x. We see our derivative there. Derivative of secant is secant of x tangent of x. Derivative of tangent, secant squared x. So this is the integral of du over u. So that's going to be the natural log absolute value of u plus c, which is going to be the natural log of secant of x plus tangent of x plus c. Well, this one is actually one of the integrals we need to know. So I'm going to take this and I'm going to factor out a secant, which on the top is going to leave me with a tangent of x plus secant of x over secant of x plus tangent of x dx. Well, tangent plus secant and secant plus tangent cancel. So this was really the integral of secant of x in disguise. So the integral of secant of x dx is equal to the natural log secant of x plus tangent of x. All right, so what about cosecant? We're going to do this like the last one, just in reverse. So to get this integral, we multiplied by tangent plus secant. So here what we're going to do is multiply by cosecant over cosecant plus cotangent over cosecant plus cotangent. So we're just multiplying by 1, but it's going to give me something like this, which we can then integrate. So this is going to be the integral of, on the top, we're going to have cosecant squared x plus cosecant of x cotangent of x all over cosecant of x plus cotangent of x dx. Okay, so we'll let u equal cosecant of x plus cotangent of x. Du would then be negative cosecant x cotangent x minus cosecant squared x dx, which is what we have but just opposite. So this is going to be negative the integral of dx over u, which is going to be negative natural log of u plus c, which is going to be negative natural log, replace u back in, cosecant x plus cotangent x plus c. So that's our integral for cosecant. The integral of cosecant is negative natural log cosecant x plus cotangent x. Okay, so we're going to let u equal the natural log of x, because du is hiding in there, 1 over x dx. This is a definite integral, so we can go ahead and just change the limits of integration. So natural log of e squared is just going to be 2, and natural log of e is going to be 1. So this integral is really the integral from 1 to 2 of, we've got 1 over x dx is du, so this is really 1 over u du, which is going to be the natural log of u evaluated from 1 to 2. So we're going to have the natural log of 2 minus the natural log of 1. Natural log of 1 is just 0. So our correct answer is A. Here I'm going to do some work to simplify before we decide what u is. Because we have a log, I'm going to rewrite that as x to the 1/2. Because this is a log, I can pull that out front. So this is going to be the integral x times 1/2 natural log of x. Well, if we're dividing by 1/2, that's really 2. So this is 2 times the integral of dx over x natural log of x, which we just investigated. So it'd still do the same substitution. U is the natural log of x, du is 1 over x. So this is 2 times the integral of 1 over u du, which is going to be 2 natural log absolute value of u, which is going to be 2 natural log u is the natural log of x plus c. So we have 2 natural log of x plus c. This one, we're going to let u equal natural log of x. So du is going to be 1 over x. And there may be cases where you pick the wrong u, and it doesn't simplify down. So then you can just switch it. But here, this is then going to be the natural log gets replaced with u. The 1 over x dx is du. So this is 1/2 u squared, which is going to be 1/2 natural log of x squared. Okay, we've got the integral of natural log of x cubed. So when you see this log and you've got a power, we want to use the power rule because it's just going to make our lives easier. So again, we're going to let u equal natural log of x, which again means du is 1 over x. So this is now the integral of 3, 1 over u, just u, du, which is going to be 3/2 u squared, which is going to be 3/2 natural log of x squared plus c. And again, u equals natural log of x, du equals 1 over x. So this is going to be the integral of sine u du, which is a negative cosine of u. So this is going to be negative cosine natural log of x plus c. Now these next three, we've got 1 over x plus 1, x over x plus 1, and x squared plus x over 1. The trick here is they all look very similar, but how we're going to handle them is going to be a little bit different. For this first one, this is simply just going to be the natural log of x plus 1 plus c, because this is just 1 over x, but with a plus 1. These ones, there's not going to be a way to do that. And we can't let u equal x because we're going to get it's not going to help us out. So we're going to channel our Algebra 2 skills, and you're going to use long division. We're going to do this division to simplify the problem, and then we're going to integrate. So we're taking x, and we're dividing it by x plus 1. So how many times does x go into x? 1. Multiply that down, gives me x plus 1. And then we subtract. So x minus x is 0. 0 minus 1 is negative 1. So my remainder here is minus 1 over x plus 1. So I haven't changed the problem, but I am going to change what it looks like. So this is equivalent to 1 minus 1 over x plus 1, which this we can integrate. So the integral of 1 is just going to be x. The integral of 1 over x plus 1 is going to be natural log x plus 1 plus c. Okay, and we'll do the same thing here. So we're going to take x squared and divide it by x plus 1. So we'd multiply by x. So this is going to be x plus 1. X squared plus x. So x squared minus x squared is 0. 0 minus x is negative x. So what would we multiply x by to get negative x? Well, minus 1. So we'll do this again. So we're going to have negative x minus 1. Subtract. So we're going to have 0 minus a negative 1, which is going to give me a positive 1, and that's going to be my remainder. So plus 1 over x plus 1. So my new integral is x minus 1 plus 1 over x plus 1. So I'll just do this straight down. The integral of x is x squared over 2. Integral of 1 is x. And this is going to be the natural log x plus 1 plus c. Right. Now we're going to go through integration of exponential functions. Integral of e to the x is e to the x plus c. That's one you just have to know. Integral of e to the negative x is going to be negative e to the negative x. And again, you can always think about taking this derivative, and this should be our result. Okay, here e to the 2x is going to be 1/2 e to the 2x, because when I take that derivative, we need to get rid of the chain rule. This is going to be the same as e to the 1/2 x. So this integral is going to be 2 e to the 1/2 x plus c. So we can generalize that to 1 over a e to the ax plus c. Okay, here we have a definite integral. I am going to go ahead and do a u substitution. So I'm going to let u equal negative 3x. So my new limits are going to be negative 3 natural log of 2, which is the same as, I'm going to go below here, natural log of 2 to the negative 3, which is natural log of 1/8. My lower bound is going to be 0. du is going to be negative 3 dx. So I'm going to put in a negative 3 here, which means I need a negative 1/3 on the outside. So this is going to be negative 1/3 times the integral natural log of 1/8 0 of e to the u, which is going to be negative 1/3 e to the u, evaluated from the natural log of 1/8 to 0. And we'll squeeze this in here. So we're going to have natural log e to the natural log of 1/8 minus 1/3 e to the 0. E to the 0 is just 1. E to the natural log of 1/8, so this is going to be negative 1/24 minus 1/3, which after you get a common denominator is going to be, actually this should be plus, because this would be a minus minus. 7/24 will be your final answer there. Okay, moving over to number 7 here. We're going to let u equal x to the 4th. du is 4x cubed. So I'll put a 4 in there, which means I need a 1/4 on the outside. So this is going to be 1/4 times the integral of e to the u du, which is going to be 1/4 e to the u plus c. So I have 1/4 e to the x to the 4th plus c. So we have e to the tangent of x secant squared x. So we're going to let u equal tangent of x du secant squared x. So this is going to be the integral of e to the u du, which is e to the u plus c. So this is e to the tangent of x plus c. For this one, okay, we're going to let u equal the square root of y, which means du is 1/2 root y dy. So I'm going to put a 2 here so that I have this. Well, that's like multiplying by 1/2, so I need to put a 2 on the outside. So this is going to be the integral of 2 du over e to the u. So I'm going to make this 2 times e to the negative u plus c. Sorry, du. So this is going to be 2 times negative e to the negative u, which is going to be a negative 2e to the negative square root of y plus c. Let u equal 1 plus e to the x, which means du e to the x dx. So my new problem is just the integral sine u du. Integral of sine is a negative cosine. So this is negative cosine 1 plus e to the x plus c. Here we're going to let u equal the denominator. So u is going to equal e to the x minus e to the negative x, which means du is e to the x plus e to the negative x. So this is the integral of this is du over u, which is going to be the natural log of u plus c which in this case is the natural log of the absolute value of e to the x minus e to the negative x plus c. Right, here I'm going to rewrite this before I integrate. So I'm going to rewrite this as e to natural log of x is equal to the natural log of x squared. Well, e to the natural log of x squared is just x squared. So this is going to be x cubed over 3 plus c. This next one here looks really complicated, but if you look at it, this is e to the x squared, so e is just a number. 1/2 natural log of 2 is just a number times sine of x. So this is just a constant times x squared and a constant times sine. So this integral, this is going to be e over 3 x cubed plus 1/2 natural log of 2 times a negative cosine x. So I'll rewrite that as minus 1/2 natural log of 2 cosine of x plus c. These next ones, the integral of a to the x is a to the x divided by the natural log of a. So the integral of 2 to the x plus c is 2 to the x over natural log of 2 plus c. Integral of 10 to the x, 10 to the x over natural log of 10 plus c. Here, I'm going to go ahead and do a u substitution. Again, you don't necessarily have to if you see what's going to happen. So I need a 5 dx, which means I need a 1/5. So this is 1/5 times the integral of 6 to the u du. So this would be 1 over 5 times 6 to the u over natural log of 6. So this will be 6 to the 5x divided by 5 natural log of 6 plus c. Next one here is a definite integral, so I'm going to let u equal negative x squared. Change my limits of integration. So negative x squared, if I plug in root 2, is going to be negative 2. 1 is going to be a negative 1. Du is going to be negative 2x dx. So if I want a negative 2 in here, I need to multiply by negative 1/2 on the outside. This is going to be negative 1/2 times the integral from negative 1 to negative 2 of 4 to the u du. I'm actually going to switch this around before I integrate. Usually we have the big number over the small number, and I have a negative here. So I can rewrite this as positive 1/2 the integral of negative 2 to negative 1, 4 to the u du. So this is going to be 1/2 times 4 to the u over natural log of 4. So this is going to be, I'm going to have 1 over 2 natural log of 4. And then I'm going to have 4 to the negative 1 minus 4 to the negative 2. So this will be 1 over 4 minus 1 over 16. Okay, if we get a common denominator, this would be 4/16 minus 1/16 would be 3/16. And when I simplify that, that would be 3 over 32 natural log of 4. So here we're going to evaluate this integral. The issue is we're going to have to use the calculator to do this. But the calculator is not going to handle an integral from 1 to 500 of an exponential function. It will be too big. So we're going to have to simplify this using rules of exponents. So I'm going to rewrite this problem as 1 to 500 of 13x minus 11 to the x. This is a plus, and I'm going to switch these. So I'm going to make this the opposite of what this is. Because these are switched. So I'm going to make this 13 to the x minus 11 to the x. And again, I did this by making it the opposite. If I distributed it back in, this is what we have. Well, now I have the same thing. So the integral from 1 to 500 minus integral from 2 to 500 is going to equal the integral from just 1 to 2, because we're taking everything from 2 to 500 away. Then you will be able to use your calculator to evaluate this, which when you do, will give you b. So those are the different types of integrals involving logarithms and exponential functions.